absolute deviation, the first thing I want to jump into is what is mean absolute deviation? Well, a lot of you said before that you kind of remember what it was. So if you look at the definition, it sort of describes exactly what it is. It's the average distance between the mean and each of the numbers in the set. So you're going to find the mean, and then you're going to figure out just how far away from that mean are each of the numbers here. And to do this, we're going to jump right in and just start with an example here. Because you're qualified to do all of these different steps. You know how to find the mean, certainly. So jump down to this table here. We're talking about the movie admission prices to at different movie theaters in a particular region or area. And this breaks it down into a step-by-step format. So the very first thing we want to do here, let's get the mean. All right, and let's write, as you're doing this, let's write it in each step here. Let's write it in the space provided. All right, so for the first step, did anyone write down the sum? What is it, Emily? 52 and a half. So $52.5. And then our mean would be, go ahead, Emily. What did it say it again? $8.75. Do you guys agree with that? $8.75 is the average price for a movie ticket in this particular set. So now we jump down to the second part, and this asks us to find the absolute value of the differences between each number and the mean. Now, let's review this quickly. When I say find the absolute value of the differences or find the absolute differences, what does that mean? Can you describe, because you'll see this occasionally. I know you've seen this terminology before, but if I said, what's the absolute difference between these numbers? Do you know what I mean, Frankie? How far they are from the mean, but what can we not have? What can we not have? Jack? You can't have negatives, okay? So for instance, and I'm not going to use these numbers up here because I'm going to let you do this on your own, but let's say, I don't know, the mean was 10, and, you know, I'm looking at a number and say, oh, okay, 12, how far away is it? Well, that's 2. And then I say, well, there's 8. Well, how far away is that? Oh, it's -2. No. These would both be two values. That's supposed to be a plus sign. These would both be 2 away from the mean, okay? So the absolute difference means positive values only, okay? So it doesn't matter if it's greater than the number or less than the number. You figure that out. So in this step here, we want to find the sum of the differences, okay? So go to each data point. So for instance, you're comparing 950 back to this mean value, and then you go to 9, and then you get the sum of those 6 values. can somebody read me through the differences that you got here? I don't care which order, it doesn't matter to me. Just take me through. Go ahead, Issa. Okay, so 0.75. Okay. 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 So all decimals here. And what'd you get for the sum on that, Issa? What was it? 3? So the absolute difference between all of these values and the mean is $3 if you wanted to say it like that. Okay? But that's not your mean absolute deviation yet. What we have to now do is find the mean of all of these numbers. Well, we're right there. What do you do to get the mean of these numbers here? Cameron? Yeah, there are 6 numbers just like up above. So you take your 3 divided by 6, and we get 0.5, or in this case, since it's money, we would say 50 cents. Okay? So the mean absolute deviation but for this set of data is 50 cents difference. Okay? This is going to be more obvious, I think, why we do this when we actually compare 2 sets of data. So that's what I want you to look at next here. Take a look at these 2 values. So let me just try to interpret this scenario for you, because maybe it does need a little bit of interpretation. We have 2 different people here, Anders and Marcus, all right, and they're apparently measuring the number of junk emails that they get, all right? And the way that I'm interpreting this is by, let's assume that this is like a daily thing, okay? So like on one day, Anders got 1 junk email. On another day, or actually on 2 separate days, he got 2 junk emails, like on those days. 2 separate days, he got 3 junk emails each day. On 1, 2, 3, 4, 5, 6 days, he got 5 junk emails on each of those 6 days. Does that make sense, what I'm trying to say? Like, so when you're looking for the sum, think of it like that. Like, for instance, if I'm adding these up on this first point right here, well, 1 junk email would just be 1. I have 2 2s, so that would be +4. Okay? Maybe it would help if you wrote them all out. Like I have 1 1, I've got 2 2s, I've got 2 3s. That might actually be a little bit easier to do then. Okay, and that's what I'll do over here. You can, but I just want, like when we go back to like find the mean absolute deviation, sometimes it's easier when they're all. What am I missing? Oh. Okay, you should have 20 data points for Anders and good, 20 for Marcus as well. So they're an equal number of days that they're measuring these. Just writing them out. Start with your mean, and then from there build off to your mean absolute deviation. So I'll give you guys some time to really work on this. Do any of you have both of the mean absolute deviations? Does anybody have that yet? Okay, I'll give you a little bit more time. I know the second one can get a little bit dicey with the decimals and things. You should have some decimals there. Let's start working through these because I know just glancing at some as I was walking around a little bit, I saw some different answers. I want to make sure we all have the same, okay? So I listed the Anders set right here. So the sum on all of these, I believe, was it 100? Okay, so then that means the mean here with 20 data points would be 5. So that worked out pretty nicely. So then you take and find the distance between the mean and all of these other numbers. So for instance, if I was comparing 5 to 1, my distance there would be 4. 5 to 2, that means that I would have 2 3s that were far, that far apart. 1, 2, 2 2s. 6 zeros. Wouldn't need to include them, but I mean, you're going to include them as overall numbers, but when I'm doing the sum, that wouldn't matter. 6s, so these are all 1 away, so I have 4 of those. And I have 5 7s, which means I have 5 2s. And then I get the sum of those, and then I divide that by 20. Okay? So when you do that, the sum of those is, you have it, Jack? 28. So you divide it by 20, and that would be, go ahead, Jack, 1.4. So the average distance that these data points are away from the mean is 1.4 places. Okay? Now we go to Marcus here, and I'm not going to write it out as thoroughly as I did that one, but it's the same concept. You take all of these data points, like 2, he had 1 2, he had 1 3, he had 1 5, he had 3 6s, etc. And then you get your sum for that one. So the sum for Marcus was what? Anybody have it written down? Do you have it, Cameron? 154. Did anybody else get 154? No? All right, let's do this. 10 and 10, that's 20. 20 plus 9 is 29. I have 1, 2, 3, 4, 5 8s, so that's 40. 1, 2, 3, 4, 5, 6 7s is 42. 3 6s is 18. A 5, a 3, and a 2. So I'm going to add these up. 5, 10, there's 28. 28 and 40 is 70. 70 and 40 is 110. 110 and 9 is 119 plus 20, 139. So the sum should be 139. Divide that by 20. This is where it gets kind of ugly. What is it, like 6.95? Yeah. So our mean is 6.95, and I know you're thinking, well, can't I just round that to 7? You could, but it wouldn't be as precise. All right, so I want us to use 6.95, okay? Because sometimes the margin of error is so slight that if you make a rounding decision like that, it could impact the data and you could come up with the wrong conclusion. So we are going to keep it what it is. And then you're just going to go through and you're going to figure out the difference between them. Like, for instance, 2 is 4.95 places away, and 3 is 3.95 places away, etc. Now, the number I got for the sum, 25.45. Can anybody acknowledge that that's, anybody else get that? No. Blank stares. Did you guys do what I just said? Did you like find the difference? Like, I'm measuring from 6.95 to 2. Well, how many of you rounded it to 7, first of all? How many of you use 6.95? Okay. So did you guys do like 6.95 minus 2 to get 4.95 and add them up? What'd you guys get for the sum then? What do you have, Nadia? 27.4? Anybody get that? All right, another one. Isa, what do you have? 30.1, anybody get that? Boy, we're all over the place here, huh? What do you have, Emily? 51.05? All right, help me out. You guys can do this with me. I got to get this through. So 10 would be 3.05. So do 3.05 times 2. You guys can just keep these on your calculator. I'm just going to talk and you guys can do it. So 3.05 times 2 plus 2.05 plus 1.05 times 5 plus 0.05 times 6 plus 0.95 times 3, and then we just have 3 singles, plus 1.95 plus 3.95 plus 4.95. What is it? 27.4? I added wrong. Is that what you all got then? Divided by 20, what is it? 1.37? Oops, 37. Okay. So now, here's our conclusion. What do we use mean absolute deviation for? Well, this is why. If you're making a comparison between these sets of data, you could see that the mean absolute deviation, they're close. And this is why I said we shouldn't round, because if we would have rounded, it would have altered this. But the mean absolute deviation for Anders is a little bit more than Marcus. Does anyone know what that means when we say that the mean absolute deviation is more? What does that say about the grouping of your data values? Or when it's less, what does that say? We need a way to interpret that. Ava? Yes, and when it's smaller, they are... Exactly. So when you have a smaller mean absolute deviation, that means the data points are closer together. So you have a more consistent set of data. When the numbers, like if you're comparing them, when the mean absolute deviation is larger, that means you have data that's more spread out or diverse. Now, if I was giving you guys a test and I said, okay, I'm going to take their points and I'm going to score it and do all this stuff, would I want your mean absolute deviation to be more spread out or closer together? I would want them to be closer together. Now, hopefully they're closer together, but on the upper end of the grading scale, I would be like, oh yeah, they're closer together. They're all in the 60s. I'm not going to be happy about that. But yeah, ideally what I would want is a cluster of scores that are, upper B, low A range. That would be perfect. So that's kind of what I'm looking for. But that's what mean absolute deviation will tell you in comparison. Yes, Jack? What's that? Because when you start looking at like outliers, I could have like this number and then like a 15, or let's do these ones, and then like a number that's way out there. It's going to create a larger range, but those are extremes. You're looking at more of the cluster that's created. So more of the numbers, where are they centered around? That's what mean absolute deviation will tell you. Okay? Now tonight, I just have a couple practice problems. It's on a worksheet related to that that you're going to do for me.